So, states of matter is one of the most basic concepts that relates to both physics and chemistry. Basically, we're looking at the concept that any pure substance can exist in the form of solid, liquid, or gas. And that's something that you probably learned when you were, younger, or you've seen it with like ice and water and steam. But moving kind of into a more mature understanding of chemistry, we need to know that all pure matter can exist in any of these states. It depends on temperature as to which state that they're in. So, to break this down to a more simplistic form, now that we have these really awesome microscopes and stuff, we know that all substances are made of particles. They're either made of atoms or molecules, or if they're a mixture, they're made of both. And this is called the particle theory of matter, that everything is made of particles. The arrangement and motion of those particles, then, will determine the state of matter. So let's look at our 3 examples and kind of talk about what that arrangement looks like. In a solid, we have the particles, if you'll notice here. Usually you'll see a picture or diagram of a solid as the particles being very kind of close together. They're packed in kind of a pattern and a formation. So they're very, very tightly packed together. And they're not completely still. When something's frozen, everything inside of it isn't not moving at all. They're just vibrating and fidgeting around a little bit. And that keeps it from being completely motionless. So because of their closeness, the solids have a fixed shape and a fixed volume. So their shape doesn't change because their particles are so close together they don't have anywhere to go. And their volume doesn't change because we can't squish them together any closer. So if we look at this little block, you can see that we can't really, squish it together anymore. They can't really change their shape. Now, in a liquid, the particles are a little bit farther apart. They're still touching, but they're sliding past each other. And if you think about a liquid like water in a bottle, how everything kind of sloshes and slides around, it's because that's what the particles are doing. The particles slide past each other. They're touching, they're just able to move at this point. They're not stuck in a very fixed pattern so close to each other that they can't move at all. So because of this motion, what we have is that liquids can change their shape. They have an indefinite shape. They'll take whatever shape of whatever container that they are in. But they have a fixed volume or measurement of the amount of space that they take because they're still touching. We can't push them closer together. They're just able to slide past each other. So we can measure their volume. They take up a specific amount of shape. They just slosh around, which, like pancakes are up here, see we can 702 milliliters. We can measure their volume. They're still touching, but they move. Now, with gases, they will take up as much space as they possibly can. They're bouncing all over the place. They slam into each other, but then they bounce off from each other. So the particles are bouncing all over whatever space or container that they have. They also move very, very fast because they hit each other, and then they hit the side of the container, and then they hit somebody, some other particle. So they're moving all the time, and they're spread as far apart as they possibly can. So because they move everywhere, and they're as far apart as they will be allowed to get, they have an infinite shape. They can take any shape of whatever container they're put in, and they also can change their volume because we can push them a little bit closer together and spread them farther apart. So here's a can of compressed air that there's air inside of. And if I kind of blow the thing here and release the gas particles, they're going to get out of there and spread out as far as they can. And you'll notice there's more air in that balloon than is in the size of the container because they will take up as much space as we allow them to. And then when I let the balloon go, then the gas will spread out all around the room. So the gas particles are trying to get as far away from each other as possible and will take up as much space as they are allowed. Now, this means that because they take up as much space as they're allowed to, that we can also push them closer together or allow them to spread apart. And that is called compression or being compressed. And if you see here, if we draw a picture of some gas particles bouncing all over the place, far apart from each other, I can then press them or push them into a container so so that they're closer together but still being all gaseous and bouncing around. And then if I release them from that container, like in that air can, then they're going to move out and get as far apart from each other as they possibly can. Okay? So, as evidenced by the gas. We shove a bunch of gas particles in there, and then when we let them out, then they spread out because of the way that they act. So to give you a little analogy, because analogies are always a nice way to kind of set in your mind, I like to think of states of matter like movie theaters. When you go to the movie theater and you sit in the theater seats, you're packed in pretty tight in that movie theater, unless you go to one of those like real sweet ones that has the recliners. But even at that, you're still kind of packed in there pretty tight. Not a lot of movement, you kind of can fidget around, but the people are tightly packed, and they're kind of wiggling around, but they can't really get up and move past each other. That's like a solid. Then, when you get out of the theater, you get into the hallways, which are still a pretty confined amount of space that you can take up, so you have a set volume. But all the people can slide past each other, and if it's like a really, really busy hallway, sometimes you're bumping into each other, but you're able to move around. So hallways are kind of like a liquid. Everything can move kind of in different directions, but you also have a very specific amount of space that you're allowed to take up because the walls and the ceiling and the floor of the hallway kind of close you into that space. And then thirdly, you get out into the parking lot, and you kind of have this infinite amount of space outside that you can take up. And as soon as everybody gets out of the door, they spread out as far as they want to. They go and get in their cars, they get away from each other, so they don't have to touch each other. Little kids are like running around and playing and stuff, although playing in a parking lot's a terrible idea, don't do that. But the people are going to spread everywhere. So, it's like our solid, our liquid, and our gas. And we can move in and out of that. With states of matter, it depends on temperature as to what's going on with those particles. Okay? So matter can change from solid to liquid to gas depending on what we do with the temperature of the substance. So here, we're going to draw a little solid patch and think about what that looks like. That's right, they're all going to be very close together, not quite touching, a little bit of space so that they can wiggle around. And if we add heat to that solid, the particles are going to speed up, they're going to spread apart, and they're going to turn liquidy. That is the key with adding heat. And then the more heat that you add, the more they speed up and spread apart and will eventually become a gas. This is called expansion. Anytime you add heat to a substance, the particles speed up and they want to spread apart from each other. Now going the opposite direction, if I take something that, it could be a solid, a liquid, or a gas, but let's take for example a gas, and I take the heat away from that gas, I cool it down, remove the heat, then when we remove heat, the particles are going to slow down and clump together, just like on a very cold day. You usually feel like you're moving a little bit slower, you want to get closer to other people if you're standing outside waiting for something, and they will eventually then turn into a liquid, and then the particles of liquid will slow down and clump together and then form a solid. We call this phenomenon contraction, and we see it in all matter. Even in like a sidewalk, if you go outside on a really cold day and you look at the lines in between the sidewalk, they're smaller than they're bigger than if you go outside on a really hot day, then all of that concrete will expand because it got hotter and take up more space, and the cracks will get smaller. So matter exists in three states: solid, liquid, and gas. Heating matter causes expansion for the particles to speed up and spread apart, and cooling causes contraction, which causes them to slow down and clump together. And that's how we get changing from one state to another.